Welcome friends, I am Tanmay. I am currently doing my PhD at Indian Institute of Science, Education and Research in Kolkata in Chemistry department. So today we are going to discuss about borohydrides. As I told earlier that I will make a dedicated video on borohydride. Today we will mainly discuss about the preparation of borohydride and few properties of borohydride. This is the first part of the video. I will make another part where I shall mainly discuss about the organic reaction using borohydrides. So let's start. Borohydrides are a unique type of chemical made of boron and hydrogen, and it is a tetrahedral geometry material. For example, this borohydrides contain sp3 boron. If you remember in my previous discussion, BH3, which we have discussed about, it is a sp2 electron with sextet, means 6 electron to the boron. It's electron deficient, but this material is not electron deficient, this is electron rich. So let's check about its hybridization. Boron's valence shell configuration is 2s2 2p1. So this s orbital contains 2 electron and p contains 1. When it hybridized into 4 sp3 orbital, then 3 orbitals are singly occupied and 1 is vacant. These 3 singly occupied orbitals form bond with hydrogen, this with hydrogen, this with hydrogen, and fourth one, it is from this fourth one, the electron pair is coming from hydride. Okay, I will explain it. So this is the sodium borohydride, and I told that it's electron rich species. Okay, and another thing that we can tune the reactivity of borohydride by tuning these hydrogens. So we will keep one hydrogen as intact and we can tune this hydrogen based on our demand in reactivity. And this tuning part I shall cover mainly in the second part of this lecture. So let's see about its preparation. So as we have discussed in our previous video that borohydride, boron is attached with hydride, so it could be prepared by reacting boron reagent with hydride, and that is exactly was done initially to prepare first time the borohydride reagent by reacting lithium hydride with diboron or B2H6 in diethyl ether as a solvent, and it produces lithium borohydride salt. Okay, let's explain about okay, before I explain again, this is one way of preparation of lithium borohydride. Another strategy to prepare lithium borohydride is reaction of lithium hydride with boron trifluoride BF3, and it produces, first of all, since we told that it will be lithium borohydride, okay, lithium borohydride, and what is pending means fluorine are pending. Another thing, 4 hydrogen here, so 4 from lithium, so 3 among 4 1 is used here, so 3 lithium fluoride. And actually in literature mainly 2 borohydrides are discussed, one is lithium and one is sodium. So let's check about the sodium borohydride also. This sodium borohydride could easily be prepared from sodium hydride plus trimethoxyborate, trimethoxyborate, and it results in sodium borohydride. And you can guess from this previous reaction strategy that another product will be NaOMe. Okay, so we will discuss these three reactions, how these reactions are happening, and I guess it will help you to predict or understand about the pathway of this reaction. So please give your attention properly here and try to understand how the reaction is happening. I will explain this reaction individually. So let's start with this reaction. For example, lithium hydride could be considered as lithium plus and hydride minus, because I told in my previous video this is the smallest molecular weight ionic compound where molecular weight is 8. Okay, this is the smallest molecular weight ionic compound, so this is lithium plus and hydride minus. And this BH3 could be considered as, this B2H6 is a dimer of BH3. Okay, although it is little bit stabilized more compared to this BH3 due to the formation of 3-center 2-electron bond, which I explained in details in my previous video. So you will read it, you will understand. So this is little bit unstable or less stable, we can say, due to 6-electron configuration. It is sextet, so it desperately needs electron. And you can see here there is hydride which is ionic, and this lithium hydride is also not that much stable because lithium is a cationic species. It is stable, but hydride, it contains 2 electrons and the nucleus contains 1 proton, and due to tremendous electron-electron repulsion, the hydride size is very big, means electron cloud is distributed over a wide area. So now you can consider that vacant pz orbital, to that orbital this hydride can attack and form this lithium from this BH4 tetrahedral, this BH4, and it seems the hydride is attached here, so it became minus. During the hybridization writing I have showed that hydride is attacked or hydride is given one pair of electron in order to fulfill that vacancy of that orbital. Here that is the story, and this is negative charge, to counterbalance the charge lithium remains closer, and ultimately this is lithium borohydride. Okay, this reaction I guess little bit easy. So ultimate tricky reaction is that reaction between this lithium hydride and this boron trifluoride, because here the main complication comes. Okay, so let's see. And another product is here lithium fluoride. Okay, as we have said earlier, this is lithium plus and hydride minus. Now main contradiction comes from BF3. Actually, if we see, this BF3 molecule is also a sextet, 6-electron species, but it's surrounded with 3 fluorine atom which has lone pair of electron, and it could be back donated to the boron to neutralize its electron deficiency. This story I have told many times, that its structure should be like that and this. But you can see one thing, after electron donation this resonance form looks like that. This fluoride contains a positive charge and boron contains negative charge. In case of boron, okay, let's accept this, but fluorine contains positive charge, that is little unusual, because in Pauling scale fluorine has the maximum electronegativity around 4, where boron has electronegativity around 2. So it is not expected that it will be so much comfortable after giving electron to boron. So it will try to regain its electron. So this is one of the canonical form. But if we see the overall electron distribution, we will find out that this electron donation, okay, there is some electron donation, but it is not enough to compensate the total electron deficiency of this boron atom. That's why after being attached with 3 fluorine atom, it is still electron deficient, and that's why this hydride form, this lithium hydride molecule attacks. And another thing, when we consider a reaction, we should consider the reactivity of 2 reagents. Okay, it is relatively stable, but this is highly unstable because the 2 electron on hydride. So this hydride will attack here, and it will form a adact, that is lithium this counter site to maintain the charge balance, and this fluorine, boron, this fluorine, and this is the hydrogen. Okay, right now it is 8 electron species. Okay, fine, but still it's carrying a charge. So there is little uncomfortable nature also, because it was hungry, but it was not capable to accommodate with that much stability under this reaction condition. So what happens? It may release that hydride again to go back in the back side. Okay, or it can release one fluoride, one option. And what will be the product if it releases? Then the product will be F, B and H plus lithium fluoride. Now you have to listen very carefully. Lithium fluoride is insoluble in diethyl ether, so it will precipitate out. Theoretically, this reaction is reversible. Fluoride can go and attack to this and form this material, and it should go this side, but it is not, because according to Le Chatelier principle, if we say rate of a reaction is proportional to the active mass of reagent 1 and reagent 2. For example, let's consider this as reagent 1 and this as reagent 2. But this reagent, and this is the proportional to the mass, but actual word is the active mass of reagent 1 and reagent 2. Please keep this in mind. This is not the mass, this is the active mass of the reagents. Okay, so since it is precipitated out from the reaction medium, so it is in very less condition, so probability of going this reaction in backside is very less, and eventually that indicates that reaction will go forward. So whatever lithium fluoride is produced, that precipitated out from the reaction, and in reaction this is present. Now if we consider this with parent BF3, you will find out here 3 fluoride was coordinated to boron, right now 2, so this is more electron deficient. So another hydride will attack again to form this FBH. So like similar process, one fluorine will go and it will produce FBH2. Similarly, another hydride will attack and will form this FBH4 minus. Similarly, like previous step, one fluorine will go out as lithium fluoride and it will produce BH3, and this BH3, and how many fluorine substitution produces the more and more reactive species, and ultimately this will react with lithium hydride to form lithium plus and borohydride minus. because borohydride is stable. It is octet filled, but BH3 is not stable. I guess you understood the pathway, and if you try to keep in mind this pathway, it will be very useful for you. I want you once again you look at this pathway and please try to understand the process, and it will be helpful to keep in mind about how the reaction is happening. So up to this study we understood that the main driving force to achieve this reaction is, number one, the excessive reactivity of lithium hydride, instability of this lithium hydride. Point 1. Second point for driving force is precipitation of lithium fluoride. Third point is the stability of lithium BF4 due to octet fill up. Okay, so I guess you have understood why this reaction is happening, and from the pathway explanation you understood how this reaction is happening. So keep this thing in mind. So last we wrote about the reaction of sodium, means sodium hydride plus BOMe. It produces sodium borohydride and sodium OMe. Here the reasons are exactly similar like lithium hydride. This lithium hydride to lithium borohydride. That's why I shall not explain it again in details. If you understood this lithium hydride to lithium borohydride process properly, I guess you will be able to explain this pathway. So right now we are going to explain the properties of these borohydrides, and mainly we will check the properties of lithium borohydride and sodium borohydride. Lithium borohydride and sodium borohydride. Okay. When we check about the reactivity of any reagent, first we check the solid state of this material, that is both are solid, free flowing solid material. Second is moisture stability. These material react with moisture to form lithium boride salt plus hydrogen gas. Why? This hydrogen is delta negative, this hydrogen is delta positive, so they combine to each other from hydrogen gas, and this process I have explained in my previous video. So you see that, you will get the idea. Similar is here also. But if we compare the reactivity of sodium borohydride and lithium borohydride is more reactive compared to sodium borohydride towards the reaction with moisture. So this is little slow, and this reaction is utilized in direct borohydride fuel cell. I will explain it in brief. Direct borohydride fuel cell means this borohydride reacts with water and produces hydrogen, and this hydrogen provides energy in the fuel cell. That is the main guiding principle for this direct borohydride fuel cell. And one thing we should remember is the borohydrides are right now under investigation for a future hydrogen carrier material, because hydrogen is a zero emission fuel with highest energy density, and additionally it is the most effective fuel for future. So this is the main property of this borohydrides. Right now there are another one application of this sodium borohydride, not lithium borohydride, that is specially sodium borohydride. What? Sodium borohydride reacts with sulfur dioxide under alkaline solution to produce that sodium dithionate and sodium boride. Sodium dithionate means Na2S2O4 and sodium boride BO2. Previously we have also shown reaction with water produces sodium borohydride and water. These SO2 is converted into dithionate. Okay. These material acts as a bleaching agent in wood pulp. It has a very good industrial application. So this is one of the biggest application of sodium borohydride in the preparation of sodium dithionate. Okay. So this is the end of the first part of this borohydrides. Here I have mainly explained about the inorganic properties towards the inorganic material. Mainly roughly you can say. But the properties to the organic material will be described in the part 2 in details. So I request you to see the part 2 also in order to maintain the continuation of this learning. So thank you everyone for listening my videos. Please, if you like my video, please subscribe my channel Chemistry the Mystery of Molecule and share this video with your friends. And if you have learned something, then inform me via comment, and ultimately hope to see you all in the next video.